There are certain angles in radians that we need to know. If we divide a circle into 12 equal sectors, and if there are 2 pi radians around the circle, then each sector is going to be 2 pi divided by 12 radians. Now we just write 2 pi over 12. We don't write the unit radians on here. We can if we wish, but if an angle is expressed without any units, it is radians. Radians are the most natural unit for angles, and that's what we're going to use. So if we divide the circle again into 12 equal sectors, each has an angle of 2 pi divided by 12, the 2 pi of the circle divided by the 12 sectors into which we're dividing it. Now, of course, 2 pi over 12 reduces to pi over 6. So we say that at this point, at the point that would correspond to where the positive x-axis meets the circle, if you had an origin at the center, we're going to say theta is 0. Then if we go that angle pi over 6, we end up at theta equals pi over 6. Now if we continue around the circle going by angles of pi over 6, we end up here at 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, all the way around to 12 pi over 6, which of course coincides with theta equals 0. Some of these angles can easily be reduced. 2 pi over 6 of course reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 will reduce to 2 pi over 3. And many of these others will reduce. 5 pi over 6 doesn't reduce. 11 pi over 6 doesn't reduce, nor does 7 pi over 6. So some of these reduce, some of them don't. But the point is that when we divide the circle into 12 equal sectors, we get these angles. You need to be able to construct this picture and to list these angles immediately, anytime you need it. And you should be able to actually construct it mentally. But if you can't construct it mentally, you should certainly be able to draw it and label it all the way around in a minute or less. If you can't do that, practice until you can. You won't regret it. You need to know these angles, and you need to be familiar with these angles. It'll be very important very shortly when we start graphing trigonometric functions. We can do the same thing by dividing the circle into 8 equal sectors. Now, if you divide into 8 sectors, then each sector has a delta theta, an angular displacement of 2 pi over 8, which is of course pi over 4. So if we start at 0, we go to pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and so on until we get around to 8 pi over 4, which is the same as 2 pi. You need to be able to draw this circle and to reduce the ones that reduce. Of course, 4 pi over 4 is pi, 6 pi over 4 is 3 pi over 2. The odd multiples don't reduce. 8 pi over 4, as we said, is 2 pi. You need to know how to do this circle as well as the other, and there's going to be more that you need to know about these angles. But this is essential for the ability to graph trigonometric functions in radians and to understand the graphs. So be sure that you understand this.